my knowledge of epigenetic effects even in the animal models that's been done at this low of dose of radiation.
Does the effects of radiation affect the gene which is used as a detector radiography?
The what?
The effects of radiation of other environmental effects we are suggesting affect the gene.
That I don't know. We didn't sequence that. It's unlikely, but it could happen.
Thank you. It's a very wonderful talk. I've been interested in the whole schizophrenic attitude toward radiation. We've had in Europe people use radiation for health effects.
Right.
Radiation baths are common.
People that have high levels of radiation in their surrounding terrestrial environments tend to have lower incidences of cancer. There's a lot of data along these lines. Ask your question and I can continue on.
So John Cameron thought that at some point, he thought that at this point we're ready for a placebo-controlled double-blind study of radiation in humans in low doses to look at positive health effects. But again, we're worried about the linear dose threshold theory, which says that at any dose radiation is harmful to us. From a clinical standpoint, what's it going to take for me as a physician to be able to get a protocol put forward where I can give a low dose radiation without look for either effects on neuroinflammation or cellular effects that would be beneficial in light of some of the respiratory policies?
I think what it's going to do for one is that, as I said before, just because we're seeing these phenomena at the agouti locus, which is what we're seeing, they're positive adaptive effects. We don't always know whether hypermethylation is going to be positive at all metastable epiallele positions. That we don't know. We'll never know all, but we've only looked at one. And there's no doubt that the epigenomes in humans and mice, for example, are greatly different, which means that we don't have any clue what the epigenetically labile targets are going to be in humans. We need to identify them. I would put my effort initially on these regulatory elements for imprinted genes. They're good biosensors, and they're also incredibly important. And we can determine whether or not these are altered in humans. So I'd say that to do that, we'd have to actually look at some of these individuals that were exposed to higher doses of ionizing radiation or exposed in utero. Other than that, I don't know whether people would still want to think about using ionizing radiation as a positive effector from the standpoint of health. As I said, I did not predict this. I did not expect this, but it's what we see.
You talked a lot about the effects of these various radiation or different things during pregnancy. And I was just wondering whether post-pregnancy treatments can reverse these effects at all, or whether we're essentially doomed by what our parents did to us.
This is what was asked before, and my answer still is nobody's really done this. These are very interesting studies to do, and I would hope, there's a lot of young people out there, and there's a lot of people worldwide, watching this webcast. These studies need to be done. I will not probably do them, but somebody needs to.
Randy, thanks very much for a very interesting talk. And I didn't realize you were starting to work on the effects of radiation on the epigenetic mark. And because obviously it's a perfect field to use epigenetic technology to try to understand what the effects are of this radiation. You see that from the molecular biology perspective. But the other thought that occurred to me as a nation, and coming from Brookhaven National Laboratory, where a lot of the research on the effects of radiation occurred, and where actually there were scientists that were proposing that low doses of radiation may be beneficial because they prime the machinery of the cell in order for it to be able to respond better if it is then exposed to a large insult. So my question comes around the concept of, in that period, and even when I was at Brookhaven, there was a lot of concern, of course, of the potential of contamination for radiation. What happened recently, relatively not so recently in Russia, but now in Japan very recently, alerted us that the notion of radiation exposure at high doses is a reality. And I'm not even considering the possibility of a terroristic intervention that involves radiation, which is also very real. So in recognizing what you are doing right now is how can we use the epigenetic tools to try to determine are there certain interventions that we can do to prevent that damage? So if you are going to intervene as soon as it happens, is there any information there? Is there any particular academic centers working on this type of questions?
To my knowledge, there's nobody working on this right now. I think now, once this gets out, there will be a lot more people working on it. The other thing is that historically, I want to make a comment to scientists in general, because I have to admit I was guilty of this myself. I heard about this phenomenon of hormesis probably 20 years ago, and I thought, to use a nice terminology, it was BS. I don't think that anymore. And the rationale for it always was, well, there's no mechanism that will allow for this to occur. But no mechanism it's really what you're saying is no known mechanism, because that we know at that time. It appears that one mechanism that allows for this hormetic response to occur in individuals and in animals is epigenetic adaptations and stabilization of the epigenome in response to radiation, and frankly, probably a lot of different toxicants. Even if this hasn't been done, but I thought about this, we can block this positive effect now at this one locus by antioxidants. Could we also block the increase in brown animals we see when the mothers ate and took in methyl donors? So in other words, is there a common mechanism where all of these are going in, let's say, through the generation of free radicals, and that's what the cell is actually sensing, and it's stabilizing the genome to allow for survival? I think this is what's going on, and I think now that there's a potential mechanism for this to occur, I would hope that we're going to see a lot more people studying this than studied it in the past.
Hey, Randy, I had a quick question. Could you speculate on why you think you see the gender differences in response to this radiation?
That I don't know, but as I said, other people have seen that also at high doses. I don't know.
I have two very intriguing observations from your talk that maybe you can shed light on the doses of radiation as related to the antioxidant effect. And in low-dose radiation, especially 3-gray, you're probably inducing mostly single-strand break, and your results with the antioxidants certainly support that. Now, the higher doses of radiation, you probably would tend to induce more double-stranded break. Would you care to hypothesize of that difference on epigenetics in terms of double-strand and single-strand break?
I'm not going to, but I can say that the field of DNA repair is intimately tied in with epigenetics, because when you repair the DNA, you have to also repair its programming. So there is going to be epigenetics and changes in the epigenome. They have to be brought back to the same level that they had before, otherwise you truly have not repaired that area. So these fields are tied together, even though initially I have to admit I didn't think of them as being tied together. And I would imagine as more people are looking at single and double strand breaks, they're going to start looking at the histone marks that are and how they're repaired, and also the methylation marks. This is stuff that will be done in the future. I will not do this, but somebody will, because it's important.
I was wondering, in the Guti mice who were treated with low doses of radiation, you saw
I can't hear you so well.
Sorry. The Guti mice that you treated with low doses of radiation, where you saw the reversal in yellow coat color, did you also see a decrease in the more severe health effects, so the diabetes, the obesity, and the cancer that occurred later on in life?
You would see that, because automatically